Welcome to AI Frontiers. Today's topic: navigating the NLP frontier, focusing on the latest advances in large language models. We'll be unveiling current research trends and some groundbreaking discoveries in this rapidly evolving field. Large language models are approaching human quality in tasks like poetry writing. It's the remaining gap between AI and human capabilities that is driving much of the research. Today, we'll explore that research and its potential impact, asking the question: how close are we to truly intelligent AI? This is what keeps pushing the boundaries of what's possible. Large language models are transforming how machines understand and process language. This episode will unearth some of the hottest research themes in natural language processing, dissect groundbreaking findings, and highlight one particular paper that truly stood out. Prepare to expand your understanding of AI and its capabilities. Computational linguistics can be viewed as a digital Tower of Babel, but instead of creating confusion, its goal is perfect understanding across all languages and between humans and machines. The foundation consists of grammar, syntax, and morphology. Common tasks include machine translation, question answering, and sentiment analysis. The ultimate goal, the summit of this endeavor, is artificial general intelligence. While large language models excel at generating text, they often struggle with reasoning. Consider this. Can an LLM actually cook a dish from a recipe, or can it merely write the recipe itself? Research is focused on developing techniques to expose logical flaws in LLMs, encouraging step-by-step explanations of their reasoning, and ultimately moving beyond simple rote memorization. Large language models can be surprisingly fragile and vulnerable to adversarial attacks or unexpected input. Think of it as a race car that breaks down easily. Current research focuses on developing techniques to detect these attacks, improving the resilience of LLMs to unexpected input, and ultimately making them more secure and trustworthy. Large language models sometimes generate biased, offensive, or misleading text. It's like a powerful engine with no steering wheel. Research is being conducted to align LLM output with human values and ethical principles, filtering out toxic content, promoting fairness, and preventing the spread of misinformation. Recent research has yielded key findings such as, LLMs still struggle with counterfactual reasoning, also known as the what-if scenario. Interestingly, LLMs can be surprisingly good at detecting sarcasm. However, LLMs are vulnerable to prompt injection attacks. Furthermore, LLMs can perpetuate societal biases present in their training data. Finally, Retrieval-Augmented Generation, or RAG, dramatically improves LLMs by enabling them to tap into external knowledge sources. Today's featured paper is titled, Interventional Reasoning for Causal Understanding. This paper focuses on teaching machines to understand causality. While LLMs can recognize correlation, they often fail to understand causation. The key question addressed in this paper is, how do we teach LLMs about cause and effect? The authors are a team of researchers from Stanford University. Current large language models often rely on superficial associations rather than true causal reasoning. The concept of interventional reasoning involves training LLMs to simulate interventions. By presenting scenarios and asking the LLM to predict the impact of specific actions, researchers encourage a deeper understanding of cause and effect. The dataset used in this research included a wide range of scenarios designed to test causal reasoning abilities. The results of the study showed that LLMs trained with interventional reasoning outperformed baseline models. The trained LLMs demonstrated an improved ability to identify causal relationships, an enhanced prediction of intervention effects, and a better distinction between correlation and causation. These results suggest that interventional reasoning is a promising approach for improving the causal understanding of large language models. The potential of large language models equipped with causal reasoning is substantial. They can help us understand and solve global challenges by analyzing data, identifying causal relationships, and suggesting interventions to improve our world. Continued research is essential to achieving this vision. LLMs can be thought of as a budding tree, full of potential. In conclusion, we've explored key areas of large language model research, including reasoning, fairness, and efficiency. We highlighted interventional reasoning as a promising technique for improving causal understanding in LLMs, and considered a future where LLMs are used to solve complex global problems. Dive deeper, explore the open source code, and share your ideas. Your voice matters in the future of AI. For transparency, this presentation was synthesized using AI tools, with GPT Google using models, Gemini 2.0 Flash for text synthesis. TTS synthesis was performed using Google. Image generation was performed using grok. A human expert review was conducted, however, some oversights may exist. All references are provided. Subscribe to AI Frontiers for more AI insights. Join the AI community and stay tuned for future explorations of cutting-edge research. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archived preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archived preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archived preprintserver.org.